Well, hello, and welcome to the program, my famous program that describes how polymorphism works. And I have this example called the pet polymorphism. The idea being you have a household. This household has a lot of pets, different kind of pets, but these pets all behave in one way or another. They may look different, but they all basically behave the same way. They eat, they sleep, they do other things. We'll leave it at that. But they're different type of pets that everybody has. So in particular, this house has 10 pets in it. Okay, so here we have an array of 10 pets. And what we have here is an array of pets. Let me show you, though, the kind of pets that this house has. I'm going to put this right here. And this is a diagram describing the type of pets that are being modeled in that program. At the root of this is the pet class. Now, this pet class basically describes how all the other classes behave. Because, like I said, pets do all act the same. And so I'm going to show you how they act the same by looking at the code in a second. But basically what we have here is the way this arrow is directed. This is a dog class, and we don't need to redefine a separate dog class because a dog basically is a pet. There's a relationship between dogs and pets, and that is that this is a situation. A dog is a pet. A cat is a pet. Basically what happens is this arrow relative to the class that the arrow comes from is pointing to the parent of the class. So bird has as its parent a class called pet, and so you can consider this the bird being the child class and the pet being the parent class. Now there's other videos that describe the inheritance, but basically what we have is dog inherits everything that's defined as in the parent, a pet. Now what are we talking here? What are we defining here? See, here we have a class called pet, and a pet can do 4 different things. Okay, a pet has a method called what am I, and you can see that I'm basically saying I'm a pet here. If you call that method, it's going to say I'm a pet. I speak. The speak returns a string, so that pet can have a method called speak applied to it, and it'll say, well, I don't know how to speak because I don't know what kind of pet I am. And so then we have a couple of bogus methods I just threw into here just to show you the mechanism of how these methods are looked up. Method and method, they have the same name, but they're overloaded. One method takes a pet, and another method will take a bird. And the system will know which method to call by virtue of what you pass it. If you pass it a bird, then for sure this thing is going to be, this is going to call this method that says pet.method.bird. And this method would be called, if you don't pass it a bird, then any other animal in your house. Okay, if you don't call it with a bird, cat, pets, and dogs, not big birds, because big bird is a bird. And so what happens is if I were to pass it a big bird, the system would match it up to this particular method because a big bird is a bird, and it would call this. All right, so the question I'm having here is, let me just show you how I'm generating these animals in my diagram. I have 10 pets. I go through every element in my array. See, right now there's no pets in that array. They're just generic. They're just nulls. We have to actually create the pets. And so depending upon this random number generator we have here, if it, 10% of the time we have just a generic pet. And I'm not quite sure why we should generate a pet because I don't know what a pet looks like. Everybody has their own idea of what a pet is. But for sure, 20% of the time I know what a dog looks like. And I know what a cat looks like. And for whatever reason, if it's not 10%, 20%, another 10%, 60% of the time we have big birds. Wow, I'm not sure. we'll leave it at that. Big birds. We'll do that. And so what happens is, well, let's run this. I think 60% of the time we're going to have this bunch of birds here. Let's see, birds, and I should probably say tweet. So, okay, let me run it again. I just want to see. Yeah, there should be a lot more birds. Okay. And we do have a lot more birds. So here's the deal. I think you could agree that I have in my array different kinds of pets. And by the way, I really should say, why does this work? Here I create a new pet. Well, certainly a new pet can be assigned into pets of I. See, pets of I is a pet. But why does this work? New dog is assigned to a pet. Pets of I is a pet. A new cat's assigned to a pet. I don't see any errors here. Why is this working? The reason is dogs are pets. Okay, dogs are pets. It's perfectly legitimate for me. Let me just throw some dummy code in here. Say I have a pet here. A pet P equals, let's see, certainly new pet will work. That's a no-brainer. We've seen that all the time. You create a scanner, you create a new scanner. That's been working all the while. New cat, new cat, that should work too. Because children are compatible with their parents. Cat is a child. That's compatible with a parent. So when you create a cat, you're creating basically a pet, but a cat might be more complicated. Children are more complicated than their parents, but they are compatible with their parents. Cats have whiskers. A generic pet doesn't have a whisker. So you can't expect a pet. Let's put that diagram back here. Say here we have a pet. Cats have whiskers. Now you don't want to put the property of whiskers inside the pet because then that would be inherited by all the children that you define off this diagram. So whiskers, dogs have whiskers? I suppose they do, but you don't think of a dog having whiskers. But certainly a bird having whiskers, but you inherit the property of having a whisker because birds inherit from pets. So in pets at the top here should generically describe abstractly what everything should look like. Okay? Don't put stuff in the pet, like say cats. Okay, paws. Okay, how about paws? If you put paws upside a pet, then a dog certainly will have a paw, cats, but birds don't have paws. Okay, they have claws. But you're forcing everything that's a child, a pet, to have claws, and that's not realistic. So that's why I'm saying children inherit from pets, and so children are basically pets. Okay, cats are basically pets. Now, if I had a cat C is equal to new pet, that's wrong. Even the compiler's telling me that. What you're expecting the compiler to do is create a generic pet and assign it to C. Now, the definition of the cat might have, well, I got whiskers. Okay? When you create a new pet, there are no whiskers in a new pet. And so you're forcing this object that doesn't have the properties of the child to be dumped inside the child. That's wrong. Children are compatible with their parents. Parents are not compatible with the children. Children are complicated. They have more properties. They have more methods. And the compiler isn't going to have you create a child, a parent, and dump it into a child because a child is oftentimes are more complicated. And that would be totally wrong to do that. So let's get rid of this. That's one thing you have to understand about inheritance and how things are compatible. Okay, so that's why all these things are compatible. These are compatible assignments. Okay, now let's get down to brass tacks here. What's actually happening here with this for loop? Basically, in this for loop, what I'm asking is go through every animal, make them speak and make them say what they are or make them speak. Now, what does this say? Okay, so for every animal, for pets of I, pets of 0, 1, and 2, it says, what am I? Okay, and this is how I speak. Let me ask you the question. What gets executed? Okay, what gets executed? See, pets of I See, what am I is being applied to a pet. This is a pet. See, pets is the array. Pets of I is an individual pet. That's the data type. I don't see any red marks there, so I can say what am I on that pet. Okay. That's what you would expect to run, right? Okay. And pets of I dot speak. Speak is being applied to a pet, and I should see this. But when I run this code, I don't see any of those things. Okay, I don't see any of those things here. Okay, 10% of the time you see this one statement because I actually went out of my way to create a pet. So let's go ahead and say, well, oh, by the way, let's not make big birds. Let's just make birds because I'm getting all these other methods here. All right, so let me just do that for now, and I'm going to comment this out. So basically, I create a bird and not do anything fancy in there. So let's do this over again. Let's run this. This is what I'm expecting here. And also, let me just get rid of this code here. I was doing some modifications to test out the code. Let's run this. This is good. This is good. This is exactly. Okay, look at this. I got a lot of birds, and I don't see any generic pets. See, I've seen what you're seeing is different things happening. See, this is the code that runs. I am a. Well, geez, one time it says bird, another time it says it's a cat, one it's a dog. And this is what polymorphism is, and this is the way you have to understand polymorphism. Polymorphism says, okay, first off, is that allowed? There's two issues involved here in the two mechanisms that you have to understand. There's compile time, and then there's run time. At compile time, the compiler asks the question, is it okay for me to call a method called what am I that takes no parameters and apply it to pets of I, to a pet? Certainly okay. That's okay, because even as I develop, if I hit dot, okay, what am I is a perfectly legitimate method because it's defined inside pet. And the same thing, pet has a speak method. It goes into the class, it says I have these two, I actually have four methods, but I have these two methods here ready for me to be used, and okay, I can use them. But that's not necessarily the code that gets run. The code that gets run at runtime, okay, the system looks at the actual object that's stored inside pets of I. Now, pets of I could contain a pet, could contain a dog, a cat, or a bird, or a big bird. Those are the 5 different classes that can be stored in there. But what it does is that the system at runtime looks at the actual item that's stored in that variable and goes to the class to look for a what am I method. So if that pets of I contains a bird, which apparently the first index contains a bird, okay, it goes up here, bird, it sees, hey, is there a method called what am I defined for birds? Yep, run that, and you can see that's what happened. Now, if that did not exist, there's not going to be an error. There's not going to be an error. Okay, I don't see any errors here. But then what happens is, if it doesn't find that method inside a bird, it will look inside the hierarchy to see if there's a what am I method. So if you have a bird, I don't define a what am I, so I'm going to inherit from pet the what am I method. See, right now I'm overriding, and that's the difference between overriding and overloading. Okay, this is overloading when you have a name and a different set of parameters that determine how the compiler decides which method to run. Overriding is saying, well, I'm inheriting a what am I method, but that's it. I'm inheriting that. And note, if I run it, hopefully, well, shit, let's do bird. I don't have a bird. Bird. Do I create birds here? Yeah, I'm creating a bird. Oh, it's working. I'm sorry. It's working. Okay. I am a pet and I cheep. Well, I should say tweet. That sounds a bit. That makes a better word. Tweet. tweet. Okay, that's what birds do. They tweet, not dealing with sheep. Okay, that sounds better. Okay, I am a pet. Why did that work? So this second element was apparently a bird because, okay, what am I has not been defined here, so I inherit the what am I, it comes up here, and I'm inheriting from here, I'm a pet. But I know it's a bird because I did go out of my way to define how a bird speaks by saying it tweets. Okay, so to make a bird a real bird, see, what the parent gave you wasn't good enough. I have to actually override what was given to me by the parent and make a bird my own particular class. I'm going to have it say bird, and now it's going to look and look like it should right there. Okay, that's the mechanism. There's two things you have to understand. There's compile time and run time. And by the way, let's go out of our way. Let's do this. I'm a dog. A dog has a bark method. Dogs bark. So you shouldn't put a bark method inside a pet. I shouldn't put a bark method inside a cat or a bird. So a bark method sounds like it should be something that should be defined inside a dog. Let's create a dog. I'm going to create this dog over here. Dog D equals new. Oh no, let's make it a pet. Pet P equals new dog. There you go. All right, so I definitely know that P contains a dog because I see it in the code, but the compiler is not that smart. If I say P.bark, it's wrong because as far as the compiler is concerned, at compile time, it's asking, hey, what's the data type of P? It's a pet. Is there a bark method associated with pets? Compiler comes down here. I don't see it. It's not there. So, and even as you're developing this, if I say P dot, you don't see any method. Oh, actually, you don't see anything. P dot. You don't see any method that looks like it barks anywhere there. Okay, because at compile time, the only thing that you can do to pets are what you see here. And all these other methods, see method, speak, all these other methods like toString, we've seen toString. You inherit a toString. Where do you inherit it from? Well, remember, pets. Every object, if you don't specify a parent, by default, all classes, all objects inherit from the object class. Okay, you don't need to put it there. It's actually extra typing, but that's what you have, and you inherit. And what happens if I say P dot? That's why you see over here there's an equals method I'm inheriting, a get class. Certainly, what I've defined inside the pet will work, but I don't see any bark. I'm not seeing any bark. Okay, so let's talk about how we can access that bark method in another video. So before I do that other video, I do have to mention one other thing. Okay, remember, I got to emphasize this. There's compile time, where the compiler looks at what you can do to a pet. The only thing I can do is say have it speak. That's the only thing I can do is have it speak. Okay, or what am I, or those two other methods that are in there. No problem. So then there's runtime. When I run this program, the mechanism is look inside the object P, which could contain anything that inherits a pet from pet. It could be a pet, or it could be anything that inherits from a pet, and see if those particular classes override what was defined inside pet. If they do override it, you're going to call those methods. If they don't override it, then what's going to happen is you go down the hierarchy. Okay, so if you say you have a big bird is ultimately a pet. If I don't override speak, okay, then I'm going to inherit it from big bird. If bird doesn't override it, then I get the pet method that's defined up here. But generally, my big bird is going to override it, and I'm going to say I'm a big bird because it goes to the actual object and runs that object's code. All right, we'll catch you in the next video. Bye.